So get ready for some MR1 content. This is my first real introduction into CNC machining. You know, CNC, this is basically 2 axis. This adds the 3rd axis. So there's actual reductive machining, subtractive machining going on. And there's a lot that I could break. So stay tuned to see me succeed or fail. Either way, it should be very entertaining.
So stay tuned to see me succeed or fail.
All right, people at home, I'm reluctantly documenting my misery on Christmas Eve. I am going to attempt my most complicated milling project to date with the MR1 milling machine. And let me show you what we've got here. We've been calling it the Rolo because it looks like that candy.
Like a Rolo.
You know, because of the way it is. So this is being milled from 2.5-inch copper solid rod. And we've got this pocket on the inside, we've got this chamfer on the outside, and I've got a hole right here. The hole is for later when I need to flip this thing over. I'm gonna tap the hole, flip it over, screw it into the base plate so that I can face off the back side of this thing. We go into the manufacturer side. I've got my 3 setups that I've been sweating over all morning. We've got the adaptive clearing on the inside. It'll do a spiral cut on the inside to mill that pocket. And then we've got the chip breaking drill operation where it will peck several times and drill this 11/64, I believe it's 11/64, yes, 13/64 hole in the middle, which is the right size for a 1/4-20 tap. And then I have this adaptive 3D clearing operation on the outside being run with 3/8 ball end mill to create this chamfer, although I don't really know why, but I've got this weird texture on the outside. I'm not sure why it's deciding to do that. I was hoping it would be smooth. So I might need to do some tweaking on this tool path here, but that's what I'm gonna attempt to do. I gotta do that 4 times, but once I get my programs written, it's just a matter of zeroing, you know, the part in the machine and then just running the same programs with the same tools. So yeah, see how it goes. There's a lot that can go wrong. I'm extremely nervous, and I guess I'm gonna bring you guys with me. So here we go. That's beautiful. Wow. Okay, so we have some success. Actually successfully milled a pocket in the center of this copper cylinder, and that means my zero was right, it means my depths were right, everything's right. Now I'm going to attempt to do something that I've never done successfully, which is change the tool. I've already calibrated the Z-axis offset using the tool setter. So I'm going to pull the end mill out, I'm going to put the drill bit in, and then use the probe to recalibrate the Z-axis offset to account for the new tool. So it should make it very easy. Never done it successfully, so let's see how it goes. All right, so it's run the tool setting routine off the tool setter. Had to use a 1/4-inch collet and squeeze it down all the way because the 3/16 collet was too small. So hopefully that's what you're supposed to do. Drill bit feels tight, it's got no run out, so. Okay, we made a hole. We made a hole. Made a hole. Right in the middle. Oh my God. All right, now we do our final tool change. Change back, or change over to the 3/8 ball end mill. Now we go recalibrate with our tool probe. We mill our outside. Yeah, there is something wrong with that program. It looks right on here, but that is not what it's doing. So I'm gonna go look at that in the computer. Okay, I believe I have it figured out. So there's my tool path. Just gonna cut down spirally. We'll see how it goes. working. All right, I am triumphant. Look at that. God, what a pain in the ass. But I have officially made the part that I set out to make. I had a few crashes, which I forgot to film. Part of it had to do with the fact that I drilled and tapped this hole, and then I have this fixture here, which I would screw this down and level it on these parallels. But as it was milling a few times, it would unscrew itself. And I had a few crashes, and I ruined my 1/2-inch end mill. So I had to switch over to the 3/8 end mill and just do a finishing pass on the bottom and just take off as little material as possible. And now it's like it's 0.870 inches. I was going for 0.875. So I'd say that's near enough to 7/8 for my liking. So yeah, I made a copper Rollo, just like we had it drawn. And this one's got some battle scars from a few crashes. These are gonna be feet for a wood stove to raise it 3/4 of an inch. I imagine there's 4 legs, so that one can be on one of the back legs. And I'll try to clean it up a little bit. But I'm trying to just have it be no cleanup, just nice precision looking machining marks and no like grinding or sanding. So be a little filing on the edges to make them not sharp. Well, it's 2:09. I've only been at this since 10 this morning. Did some work yesterday, but I've got a process. I've got to redo my file for the inside pocket because now I don't have a 1/2-inch end mill. I have a 3/8 one. So I got to output that file, but everything else should be the same. I should be able to run my drill file. I should be able to run my outside chamfer file. And the hard part about this giant stock of copper is cutting it on the bandsaw is awful. The blade walked real bad, but I don't really have another option. I may try to cut this on my tiny bandsaw just to limit damage to the big bandsaw. Okay, a little check-in on this project actually. It's been going very, very well on this second part. I've just jinxed myself, of course. But here we go. Here's the second part. We've cut the inner pocket, we've drilled our hole, and we've cut the outer profile. One thing this machine can do, the MR1 gantry mill, is thread milling. And I have some of the thread cutters. The one I'm gonna try to use, so I'm gonna try to mill the threads in this 1/4-20 hole. So I don't know if you can see that. That is a thread miller. It's a skinny shaft with some specific cutters on the end. There's 4 of them. This particular one is Langmuir 4FL 138-625. It's all loaded in Fusion. You know, I pulled this tool out of the Langmuir tool library in Fusion. Pretty sure it's not gonna bottom out. I'm fully expecting this tool to just get totally destroyed. But on the off chance it works, I wanted to bring you guys with me. So you can see what it's gonna do here on the screen. It's gonna go down and then do a bunch of spirals. So without further ado, let's see how this goes. Oh, I'm so nervous. Is it working? That would be insane. If there's a threaded hole in there, I truly do not believe it tried to cut them. It is impossible to show you guys that. So my parameters are right, but my depth of cut is not right. The cutter survived. So let me go look at my program and see what I may have gotten wrong. There's no way I'm gonna be able to show you guys this. I'm just impressed that a tool that small got pushed into a hole that small with a machine this powerful and with a program I generated and didn't completely explode. So shout out Fusion 360, shout out Langmuir. Curious if there's a setting I missed. I wasn't even going to mind tapping this hole, but I know I had the cutters and I found the setting on Fusion. So, okay, so I just realized something. Each thread cutter is meant for one type of thread. So I used a thread cutter that was too small, which is why the threads barely got cut in the hole. So I need to use the thread cutter that is meant for a 1/4 inch hole, which is how they're titled. Right here, 1/4 inch thread mill. And then I can simulate this. Goes down, goes up. All right, so now I've recalibrated my Z-axis with the new tool. Gonna go up, gonna open my new program. 14 thread, 1/4 thread. So you'll go XY0 just to get it over there. Again, I fully expect this to explode. So if it doesn't, it'll be an absolute miracle. If it does, at least I'm filming it. All right, you ready? You go down the hole. It's cutting. It's cutting. The cutter survived. Again, if there are anything that resembles threads in here, I will be blown away. Those are definitely not threads. I don't understand thread milling yet, obviously, but again, the fact that I haven't blown that bit in half, consider that an achievement. It's almost 4 o'clock. I've got a process down for these now. Rest of what I've made is pretty nice. I might take a look at the thread cutting program one more time to see if there's anything obvious I missed, but otherwise I'm gonna move on. Gonna clear it now. Ladies and gentlemen, I think I may have some threads. Let's see. Okay, it was doing something, but not enough. There are some threads there. Problem is, to find pitch diameter offset, the only thing I've been able to find is some guy, Daniel, on the Langmuir forums. He said it was 0.02 per pass, but he didn't say what the total pitch diameter offset was for the 1/4 20 thread cutter. I don't know how far I need to go. I can't seem to find the answers I need. I don't know. Somebody knows the answer to what I'm looking for. All right, hi everyone, welcome back. And I'm continuing my journey on this copper foot project. It's really, I've spent an absorbent amount of energy on something that I'm not gonna be able to charge much money for, and that's actually not that complicated. But what has been so exhausting is like, this is my first ever CNC milling project. So every step is something completely brand new for me. It's something that I've never done before, have to teach myself, and I go really slowly because I don't want to mess anything up. So right now I'm gonna just I'm gonna write a really simple facing project. So this is the piece I'm making. Now this one I'll need to do a little bit of grinding, a little bit of polishing, because I had a crash and it got some tool marks in it where I didn't want tool marks, but that's the part. So it's a tapered, truncated cone with a recessed pocket, a tapped hole, which doesn't need to be there on the final part, but will be covered up by the foot of the wood stove. So this is going to be for a guy's woods. He wants some, he's got a lot of copper stuff at the house. The place is actually named something copper, or the copper something. Got a custom house built, and he likes cool stuff. So these are gonna elevate this wood stove 3/4 of an inch, which is important because he needs to have the tubing align or something like that. It's a crazy project. It's a lot of effort for something that could easily be accomplished elsewhere, but it's given me the opportunity to learn a new machine, and this guy will have some pretty cool parts at the end of the day. So it's got a pocket on the inside, you know, it's milled flat, recessed pocket, and then it has this tapered outer surface, which is milled with a ball end mill, a bunch of passes around the outside. And then the threaded hole in the center that I drilled using this machine and just learned how to tap. This thing can do thread milling. So I've successfully now thread milled 1/4 20 threads on the inside of this after the hole got drilled. The hole is so that, here's part number 2 of 4 in the machine right now. The hole is so that I can use one of the 1/4 20 holes in the base plate of the MR1 and turn this thing upside down, use a 1/4-20 stud and some 1-inch riser blocks, and screw this thing down to the fixture table so that I can mill the bottom side. Because you can't hold on to a cone. It's tapered. So square vice jaws do not allow you to hold onto this cone, and I don't want to mar the surface any more than I already have. So how do you hold it down and be able to cut the top? You know, you can't clamp it down because the clamp's in the way. So my idea was to screw it down. The only risk here associated with screwing something down is that something can be unscrewed, and as it unscrews, it would raise up. That's what happened on this first part. I actually broke a tool and kind of put some love marks in this one, because as I was milling the back, I was being too aggressive with my material removal, my chip load, and it came unscrewed and it backed up into the cutter, and we had a bad time. So the way I do this now, I saved it. This is the bottom side of the first part, which has been successfully machined. The only thing to do is to take off as little as possible during each pass. So you can see here, you can see where the part is and where I want the part to stop and where I have waste material left. So I was able to cut it in the bandsaw, but holding onto this thing, it's really difficult in the bandsaw. I had to use my fixture block to hold it. And yeah, it's a nightmare. I could have cut it closer, but I didn't want to risk cutting too close. And I was like, well, I can just write a script for this thing to mill. So I have to mill, I took my measurements, I have to mill that much. It looks like about 3/8 off the bottom of this. And I should only take off 20 to 30 thousandths per pass. But because it's CNC, I should be able to write a script to where this thing will just do however many facing passes it takes to get from the existing 0, which is now here. So if I go XY0 here, I took a reference off of this face and a reference off of this face, and now my XY0 is over here as if this was a square material. And now my Z0, if I hit the Z0 button, is I took two roughing passes off of this face, and then after I cut the last face, I re-zeroed my Z. So the Z0, this tool, when I zero my Z, is at the same plane as the top of my stock. So all I want to do is write a script. This will be the last script I write, and everything else at that point will be on the flash drive for the MR1. So all I have to do once I write this last script is material loading and tool changes, and I should be able to just make the next 2 parts a lot faster because I've fine-tuned my programs and I've gotten all the issues figured out, theoretically. So I'm gonna go write a facing script, a facing program to mill off about 3/8 of material and end up with a 7/8 inch thick piece, which I can then unscrew, flip over, and I will have my finished part. The goal is to make 4 of these. So I gotta write a script or a program. Now, I should say, on the note of facing, within the cut control here for the MR1, there is an automatic facing program, which you can use. I used it to square the back face from my bandsaw cut. But the problem here, unless I'm missing something, is you can only do one facing operation at a time. Like I couldn't say, I want to face off or rough face 3/8 worth of material, but I want to do that in 30 passes. You know, it's going to take all that material off in one pass. Because see, I can go my depth, my final depth. There's a little imagery there. You know, there's your stock and there's the depth, removing material off the face. But I'd have to do, like here, I'll show you the rough way. So my last pass was at 40 thousandths below the top. I come in here with my thing and put in 0.06, which is another 20 thousandths, and then front left 0, generate program. So that just generated a G-code program inside of here without me having to go back to Fusion. And what I'll do is just show you where that is. So I'll just put it over here so it gives you a start location, clamp my light to it, and then dance around the cameraman, and then hit start. And so this will take another 20 thousandths off of this. And I'm going real light on purpose. Let the coolant. I'm going real light so that I don't have any issues with the... Something's wrong. I know what I did. I zeroed my Z. So I'm actually taking 60 thousandths off. See, I almost got in trouble again. You got something on your lens. I almost got in trouble again. Because right now, I was taking 60 thousandths off, which is way too much. So I need to fix this now. This is good. Instead of a 60 thou depth, I'm gonna go 0.02, 20 thousandths. Generate that program and hit go. So now I need to run this program 3 times to get back to an even plane. And it's gonna cut air for that first section because it already milled too much. And you know, this cutter, you know, it has a depth. It can, 3/8 cutter can probably, 3/8 cutter can probably mill, I don't know, maybe 3/16 off at a time, 180 thousandths or so. Probably not. There's a chart that comes with it. But I'm not gonna cut at max depth because I'm just concerned with this fixture unscrewing itself. That's the whole point, is I want to create as few vibrations as possible so that my part doesn't unscrew itself from my admittedly janky kind of rig. But so, that part ran, and now I can step down to 40 thousandths. So 0.04, enter, generate program, start. And this is pretty easy. Like I could sit here and just do this all the way down, but I'd rather learn how to write a program, you know, continue to learn how to write programs faster and better. And that's the whole point. CNC machines are made so that they do the work for you. You just have to tell them what to do. Okay. All right, so now, I should only have 20 thousandths lip left. So now I go to my facing again, change my depth to 60 thousandths. So my final depth is 60 thousandths, but because I've made 2 more cuts, you know, it's just 20 thousandths at a time. So generate program, start, and I'll be right back.
So essentially you can manually face this, but by using Fusion, you don't have to calibrate it and start it every time.
Yeah, I mean, if I haven't simply explained that yet, I could sit here and change the thickness for every pass, and I'd have to do that for, I don't know, 20 passes. But that's really stupid because this is a CNC machine. You can program it all, you know, in the backside and just have this thing do all those, whatever it is, 20, 30 passes automatically. It'll step down a certain thing every time. And you can program that in Fusion really easily. So that's what I'm gonna do. But to do that, you have to get some data first. So that's what we do now, is now that we've got a flat face, I need to take my calipers, see how thick it is, which we can compare to how thick we want it to be, and then tell it to mill that much off. So I'm gonna use the back side of my calipers, measure that part. So our part now is 1.18 inches. 1.18. So this whole part is 1.18 inches tall. We want to mill this top part off, which is actually the bottom, and we want to end up at 0.875. So you can do all this in the computer, but 1.18 minus 0.875, we need to take 305 thousandths off, or, you know, kind of just under, between 3/8 and a quarter. So this area up here we need to mill off is 0.305. Okay, so now we go into Fusion and program that. I know how to do it, but I don't want to mess with any of the files that I've created thus far. But they've already been generated, so they're already done. make a part that reflects what I have. So I'm gonna make a circle, 2.5 inch circle, and then extrude that 0.875 inches. So that's all I'm gonna tell it that I wanna make. And I have my cutting parameters here that I printed out from Langmuir. Okay, so now if I did my job right, should be able to plug this, and I'm still working on making a network folder on here, but one thing I learned the hard way, before you go anywhere, Z up. Because if I load the program and hit go, or go to my Z0 point or anything, while that thing's down, it doesn't always go up very high before it moves laterally. So go to my XY just to idiot check myself. Okay, and now I'm going to go in here, I'm gonna open, got my backside facing program, open that. And then I think I put my origin in the wrong spot. Well, I wanna hit start just to see. Yeah, I am in the wrong place. My origin point's in the wrong spot. Yeah, so now my axis is right. Oh, I didn't recalibrate my Z0, so hold on, I gotta stop. So here's another important part. So when I did my rough facing, after I cut my last face, I didn't recalibrate the Z axis. So if I go to Z0, technically speaking, I am 60 thousandths, test my theory. See, I'm above my part, 60 thousandths above the part. Re-zero my Z. So now it should be right. So now I'm going to start this program. Yep. And we're cutting. So it'll sit there and run. It's gonna do 15 passes, and the part should be the right thickness by the end of it. Nice and chill. I'll watch it for a little bit, but once I know it's off to the races, I'll go back to the bandsaw and cut my next slug for part number 3. And then theoretically, it should go pretty quick. I'll be able to show you guys all the passes. Coolant kind of screws up your shot. All right, I'm gonna step away. And you can leave that open for filming if you want. You want to set up a time lapse out here. Copper is a pain in the ass to cut, unless I'm missing something. So the first time I tried to cut a chunk of this copper off, I did it in the Ellis bandsaw, which is a dry saw. And I set my feed and I just walked away from it, and I came out and the cut was like super not square. So then, you know, I tried to cut it with a million other things. You can see here a little evidence of lots of cutting attempts with a sawzall and hacksaw. Turns out it's just, and it is my theory anyway, it seems to be working. Copper's really soft and it galls up real bad. Copper and aluminum they're soft metals. So when there's friction applied or it gets hot, they get softer. And my theory was that it was ruining one side of my bandsaw blade. And so because teeth of a bandsaw blade are staggered, that's how the blade cuts true. If one side of the teeth gets filed down or ruined, the blade will wander. It won't cut straight anymore. So the way I'm finding out to get straight cuts is just keep the blade lubricated. And it's not perfect, about a 16th wander there, but you know, I'm milling the part anyway, so it's good enough. So takes a little longer to cut, but at least I figured out how to do it square. Okay, so that's my bottom, and then we'll mill that side. I haven't heard the machine explode yet, so that's good. Still going. You can see here the progress bar on your file. there's not a percentage number, but you know, it's gone that far and I got that far to go. Almost done. So these are the first parts here that I ever made successfully. These parts are how I hold my round stock in a square vise. You can see there's evidence of a little mess up there too. But yeah, the first parts I made were actually tools, fixtures to hold my part.
Real quick.
Yeah, they're under that garden hose. There's a whole thing of...
Didn't get any of the eyeballs, but they got close enough that I was like, you know.
I mean, technically speaking, every time you're out here, you should have those on. Why they're there, they've been buried in a tub for months. It's probably the last pass. Yeah, that's nice. I brought that over here for that.
Good call.
This is probably the last pass. Yep. There it goes. All right, now, moment of truth. Is it 7/8 of an inch? I overshot it by a lot. Damn, that sucks. How'd I screw that up?
Oh, you bucket asshole.
I swear, if you have a scar, exactly the first thing you're gonna hit on something. Just gonna bleed. Well, here's a really nice part made incorrectly. Look at those milling marks. Good job, Tay. They are not the right height. God, how did I overshoot that? I wonder if something happened with my 0 point, my Z0. But I measured, I wonder if the difference there is literally 60 thousandths. I bet you it is. God damn it. God, it's such a good part though. 0.82. Okay, so I've got to make 3 more. Well, fine. Nothing worth having is easy. Shout out to our action cams. Woo, look at that blood. That's good. It's on my favorite finger too. These action cams put up with a lot. Good job, DJI. Coolant is a special liquid though. It's not like water. It's got some oil in it. You know, it's meant for lubrication, so it takes a little extra work to clean it off of stuff. Okay, so my X and Y are zeroed relative to that cylinder, and now I need to zero the Z, so I need to do a Z touch off. So I'm gonna turn the spindle back up to 1,000 RPM. It's gonna come down. It's a more precise way to do this, but I'm just gonna touch off somewhere. So I'm gonna creep down 1,000th of an inch at a time until I see it make contact. Okay, it's touching, so I'll hit Z0, and then we'll wrap it up, turn the spindle off, go to my XY, and now I'm gonna do a facing pass just to clean it up, 0.02. Generate program, hit start. I'll just do my rough facing. Then I'll zero and start my program. Definitely a high point on the side. But I'm not worried about it moving now because I've got a really good fixture. All right, and you can see that? See the part that was milled and the part that wasn't milled. So this over here is my low side. So I'm gonna run this program until you can see milling marks on the whole face, and then that's my nice flat 0. And I'll re-zero my Z, and then I can start running my pocket program and my drilling program and all that. I've left enough stock. There should be 1 1/4 or 1 1/8 of stock sticking out of my thing. So I have plenty of extra material to mill off. All right, so while I have this tool in the machine, I'm gonna use the touch probe or the tool setter and calibrate that thing so that when I do my tool change, all that's done. So if you look over here, there's the tool setter, and that's what that thing is right here. So what that allows you to change tools, and it will automatically calibrate your Z-axis. But you need to start by calibrating it with the first tool, which is this 3/8 end mill. So I'm gonna go over here to calibrate and hit continue, and it's gonna zoom over there and touch down. Okay, so now it knows where that probe is, and I've calibrated the Z-axis offset. So now when I do my next operation and do my pocket milling, and I need to change my tool to the drill bit, I just put my new tool in, and then I hit this button here called Auto Tool Set, and with the new tool in, it'll go over to that tool setter, touch down, and then no matter how far in you put your tool, it'll calibrate that Z-axis offset, and so it knows exactly where that tool is. So that part is crucial, because if I took my tool out between steps without doing that, I'd be screwed. I'd have to redo my programs, I'd have to recalibrate my Z-axis, I'd have to calibrate my Z-axis on a surface that isn't there anymore, if that makes any sense.
Pretty useful little tool.
It's great, and it works. So now we were zeroed, everything's right. So I have my programs in here. So I'm gonna go to my initial pocket program, open that, and you see where it's gonna be milling, and then hit start. Get it out of the way, see how we did. Awesome. So smooth, and make sure everything's going correctly in the Z direction, 0.130. So very close. Oh, there you go, look, 0.125. So we just milled an 1/8 inch recess into the top. That tells me that my Z-axis and all that's right, so we can move forward. So the next operation, I could do this in any order I want because I don't have them drawn. Next, I think I'll drill the hole in the center. It doesn't matter which order I go in because I got to change the tools 4 different times and they're working on 4 different pieces. So I will Z up, I will hit the send to front button, bring this up here to the front, and then here's a top tip. Put something soft underneath your tool. Because I literally broke an end mill earlier by removing it from the collet, and I didn't have a hand on it, and it dropped. It hit the bottom, and it chipped a tooth. So, boink. See? I caught it. Because you need both hands to use these wrenches. All right, so there's operation number 1. Operation number 2 is this drill bit, 13/64, which is the hole size for a 1/4 inch threaded hole, 1/4 20 hole. So we'll take our collet completely off. Collet's an ER20 collet. Pop the 3/8 centerpiece out of it. Come over here to the 1/4 inch one. And so there's no, I don't know if this is wrong, but this is how I've been doing it. This drill bit is 13/64. The closest collet I have to that, collet's not like a chuck. A collet is a predetermined size. Yeah, so this 3/16 collet, it fits when it's free like that, but when you snap it into the collet holder like you're supposed to, and then start it on the spindle, you always want to make sure everything's really clean. I can't push this into the collet because it can't expand far enough. So what I've been having to do is use the 1/4 inch collet, which is really big, but you just squeeze the collet down more and it grabs it just fine. So the drill bit's in there now. And when I turn the manual spindle on, looks pretty true. So it's okay. So now the first thing I got to do, now that I've changed the tool, is go to auto tool set and hit continue. So this thing is going to go over to the tool setter, just goes down until something happens. And there it is. And then it touches again. Okay. Then you get a message over here. Auto tool setter routine is complete. So we've recalibrated with our new tool. So now all I have to do is open my drill program, center hole, open, and hit start. The chip clearing could be a little better. And there you go. We have a hole. So we got our hole drilled. And now we'll bring it back to the front and pull that drill bit out. This is the longest part. This is why CNC machines have auto tool changing, because you can spend a lot of time changing tools if your part has 5, 6, 7 operations in it. You know, I'm using an end mill, a drill bit, a thread cutter, a ball end mill. So I'm using 4 different tools, and I have to flip to do another facing. So technically it's like 5 changes because I can't do both my facing at the same time. So I technically have 5 tool changes. Yeah, a lathe would be the only way to make this. Actually, the lathe, it wouldn't be that bad. Oh, let's see. Let's cut our threads. One thing that's cool with Langmuir, this is done elsewhere, but you can do it on a machine like this, is you can mill threads with what's called a thread cutter or thread milling bit. Very strangely shaped bit. I don't know if you're going to be able to see the tip of that thing. See the cutters? So it just goes into the hole and it spirals out of the hole, cutting the threads on the inside. And I successfully did it. The hole in this piece right here, the threads were milled by a thread cutter, not a tap. And it's a really tight fit. I'm very, very pleased with that. I've literally never done that before in my life. So pretty cool. So we snap our new collet in, grab our tool, snug that up. Now we do our tool setting routine again.
Watch a little light comes on and touches.
And you see it here too, down here. Got tool set, that'll light up. Doink. Okay, so that's been set. So now I open my thread cutting program and hit start. It's a little crunchy there because the chips, I think, were building up in the bottom of the hole. So I'm gonna run that again. So crazy that that's possible. Dude, I mean, a thousandth or two in the wrong direction and that tool snaps right off. All right, moment of truth. And those are some 1/4 threads, my friends. It's a little tight, but that's really impressive. I just threaded copper without using a tap. That is very cool. All right, I gotta home the machine because I bumped it into the backstop. But nice part is when you home the machine, it doesn't lose your zeros or anything. So now when this is done, we'll pull that tool out. We'll pull the ball end mill in there and we'll mill the chamfer on the side. And then we'll flip this thing over and I may just mill everything off the bottom. I don't know. Cutting this in the bandsaw is such a pain in the butt. Outer slope, open, start. You can see over here what it's cutting. So we're milling the outside of this thing. So with every revolution, it's moving out as it goes down to create that cone. And you can do this in as many steps as possible. I chose to do a lot of steps so that the end result is a really smooth cone. I'm gonna go cut another chunk of copper. All right, there's a big reveal. So far, so good. That is a really nice part that I would love to not screw up. But see, here's the problem. I've got all this stock now because of, I need to have stock on the bottom to grab, as you see now with the fixture. Now I could probably have made a smaller fixture and cut less stock. These are all things I'm learning about and ways to improve. But, I gotta cut. Last time I cut like that much off and then milled the rest of it. There's no reason why I can't just mill all of this, but the sad part is, it's just turning all of this metal into chips instead of something that I can keep. It's copper, it's expensive. I mean, this guy said he bought me extra material and for the sole purpose of making 4 of these, which I'm glad he did because we both knew I would screw a few up. I don't know. Will this much milling shake it loose? I should probably cut it down as close as I can, but I don't know. I might just get the rest of them to this level because I know how to do that and I can do it successfully, and then just figure out the rest of it. I could use my fixture to coarse mill a lot of this. I need to use parallels. Greasy, nasty. What a strange pieces of equipment become very familiar when you're milling things, like a rag. Use that a lot. All right, so if I set my parallel down there, set this parallel down here, I've raised my fixtures up. I wonder what that looks like. I used my parallels to raise my fixture blocks off the vise to grab on the solid portion of the copper instead of the tapered portion. Doesn't grab as much as would be ideal, but the thought here is, can I hold the piece better so I can mill the back more? Take a bigger cut per pass because I know it's not gonna move or unscrew like it would in the other fixture. So what I could do is do most of this off and then switch to my thread-on fixture for like the final milling to get it perfect. But I could rough mill it in here because I'm holding onto it better. That's the thought. But it's not perfect because it's wanting to lift up a little bit, which is normal because I know what to do. I need just a little disc of copper. I need a 2.5 inch circle, that thick. I'd love to mill this down to where it's like a 1/4 inch thick, and then I'd have the perfect piece jig this thing the right way. You're trying to clamp it like that. Oh, that wouldn't work. Never mind. Yeah, that wouldn't work. But so, I'm trying to clamp it like that, and you can see the problem. I'm just holding on to the tapered part. Well, if I raise these up off the ground, I can clamp onto the solid part, but then as I clamp, they rotate like this because it's tapered. So they buckle and they pick the piece off the top. So if I had a real shallow disc, I could put at the bottom, keep them from buckling, but that wouldn't work. That doesn't make any sense. I think by now you guys should be able to see the extent of the issue. This has been the hardest part of this whole project, is to figure out how to cut this, sever this part from the billet when it's finished. I need that little copper disc. I got it. So we put this guy in here. Like so. And this the rest of the way. Slide it out here. Let's see if we can complete a cut with that sketchy setup. That was very sketchy. Okay, I actually got really close that time. Maybe an 1/8 of an inch material left. Oh God, it's the first one I haven't dropped or scratched so far. Let's not change that. Not the best threads in the world, but. So our end mill on. This one I'm just gonna do, I think this is the way to do it. I'll cut it so close that I can just stand here and do manual facing paths from here. That way I can creep up on it and get it the right thickness. So we'll take the ball end mill out, we'll put the straight end mill in. I'll have to re-zero everything because I've taken my part out of my fixture and moved it. But then I'll be able to face this and I'll have one, technically two done, but one that's perfect. Hello everyone, back at this fucking goddamn project again. Now we're back here at these copper Rollo project and I'm having mixed success. This one's the right height, this one's too tall and not parallel, and this one got milled too short. So despite all my effort on this piece, it's not tall enough because I milled too much off the backside. This one I need to take another pass at. I did have an incident at the end of yesterday where I got my Z offset wrong and I took a huge chunk out of the side. I'm very lucky it didn't unscrew from the fixture. And I caught it after that first pass, but you know, this is still savable. It's just like, you know, it looks good on every side except this side, so it could be placed at the back. This one got a little eaten up when I had the crash, but I can polish that one out. So I have two, kind of, and I'm working on a third, but after all my bleeding on about this yesterday, I forgot to use my tool setter to calibrate the Z-axis offset for this first tool, which I've used to cut the first pocket, this indention pocket in next billet. And I changed to my drill bit before I calibrated my Z-axis offset. And so now I have to manually calibrate my Z-axis by inching the drill bit down to the top of the part until it like just kisses it, which sucks, but that's where we're at. And I only have enough material to do one more. So if I screw this one up, like basically I have to have 100% success rate at this point. So that's all. I have so many other things I need to do too, and there's absolutely no way I can charge the customer for all the time that this has taken because it's learning. You can't charge somebody to learn something most of the time. So just trying not to panic. I actually have to recut this spiral because I messed up my Z-axis earlier than I thought. That's okay, so this will allow us to get back on track. So now I will run my initial pocket program again. And then I'll use the tool setter and get back on track with my Z-axis offset, and I'll be good the rest of the part. It's a lot of steps to learn. If you forget one of them, you're screwed. But I'm learning the hard way. It's my favorite way to learn. Z-axis calibration complete. Now I can bring this thing to the front, change my tool. Drilled our hole, change tools again, put in our delicate little thread cutter. Okay. Do auto tool set, go to our 0 thread program and start. Run that one again just to make sure the threads are clean. All right, let's mill the outside here. Outer slope. Program has completed. Well, that looks like shit. I must have got my Y offset wrong. Yeah, I didn't zero the machine that way perfectly. We're just gonna have to clean that up on the sander. Boy, is this difficult. Round things are way harder than square things. Yeah, this really probably was the hardest possible project to start on. But if anyone knows me, that's pretty on brand.
Think how easy the other stuff's gonna be now.
You shut your goddamn mouth. He who hath but only need to hold the camera. See, I got my front to back offset wrong, so I'm gonna have to clean that up manually. God, every single one has a completely brand new problem that I've never experienced before. What an incredible experience. All right, in with the last billet. Problem is, I'm having to touch off at the perfect tangent point here and the perfect tangent point here to assign a circle. There's the touch probe that this thing has. This thing, which is meant to mount in the collet and be able to sense your stock and zero things automatically, but I think it can do a cylinder. In fact, I know it can. I'm bleeding again somehow. But when I first used this thing, it had a dead zone one of the 4 directions, it pushed it way too far before it actually registered. So I don't trust this thing right now. And therefore I'm having to do it the hard way, and the hard way, it's hard, I'm not good at it. There's probably a better way to do this and blah, blah, blah. At this point, I'm just trying to get it done. So the idea is center it the best I can, turn it on, 1,000 RPM, bring it in, switch to 1,000th per step, and need a flashlight. Okay, so it just kissed it. So that was my X direction. So I go X minus 0.1875. So you set the X 0 to 3/16 of an inch to the right of where it is now, because the bit is 3/8. So you do half the diameter of the bit. Look center. I'm just one peck at a time, thousandths of an inch at a time. Okay, it just touched it. So then I go to my Y and I go minus 0.1875.
Can you go off site or sound for that?
Visual, I can see it when it starts to chip away at the material. And so now I do my Z offset. I can see that there's a high point, so I'm just gonna guess. Same thing, get close and then go 1,000th at a time. Look for that witness mark. There it is. So there's my Z0. So now go up and then turn the spindle off and send the machine to XY. Looks good. And now I'll do facing pass, because the cut's not square, so I gotta square it off first. So that I do in here. Do a depth of just real shallow at first, 5 or half a thou, no finishing pass. Generate program. Let's see, let's line the coolant back up. Okay, and hit start. Just get our baseline going. I'm always nervous at first interaction.
After you face it, you have to reset your Z.
Yes, that's what I forgot to do. Because once I face it, now I have the top of the stock that the program is going to be reading from. So to notice, it's cutting right here. It's cutting at a Z height of minus half a thousand, or 5 10,000ths. So that is the height that I set it to and then zero it out at once I have my face completely faced. Generate, start. Now we're taking 20 thousandths off. It's still probably not going to get all of it. It's cutting more, but still leaving some on the table. Quite a bit, actually. Whole backside's real low. 40 thousandths. Take another 20 off. This cutter's getting dull, I can tell.
Starting to sound the thing.
Well, and you get stuff like this. You shouldn't really be getting long strips. That means it's sort of bullying the material off of there instead of cutting it. So that's not great. One more pass.
So with the bits on these, are they things that get resharpened, or are they?
No, you can't sharpen end mills because then they'll change size.
All right.
They have to be a specific size. You can sharpen drill bits because you're just sharpening the cutting teeth, not the diameter, not the flutes, but end mills cut on the end and on the sides. So when you sharpen them, yeah. So you throw them away is what you do. Which is unfortunate because they're really expensive.
I hear that you make them into Damascus, or you can turn them into Damascus blades.
Oh yeah, well yeah, it's tool steel. It's carbide. Here we go, we've got a faced part. Now we can go ahead and run, let's see. So that was at 60 thousandths down. So I'm gonna go to my Z0 and then move it 60 thousandths more, 60 thousandths down, and then that's my 0. So now I have my Z0 is the same as that milled surface right there. So I'm ready to run my program. All right, look it up. Initial pocket, open, and go. Here we go. last one. All right, there's your pocket. But I'm thinking down the road, thinking about when I go back to mill the bottom side, I'm gonna use a 1, 2, 3 block and put it over this stud to try to get. So my issue with this one, the last one I did yesterday, is that when I thought I was milling it, the bottom flat, got weird numbers, you know, so that's 0.9. If I take a measurement over here, it's 0.885, and then here it's 0.88. So this, I did not mill the bottom face parallel to the top face for some reason. And so probably because the way I had it jigged up, it just wasn't flat. So I think I'm gonna use a 1, 2, 3 block, which is a precision, well, they're precise enough. We've used them for other things at this point, but slide the 1, 2, 3 block over my stud here so I have more surface area supporting this. Hopefully that gets it square enough to where I can take another finishing pass off the bottom of this and get it to the right thickness, thus saving this one and making it my best one so far, theoretically. Z calibration with my tool setter. All right, so.
This titanium bit?
It's titanium nitride coated, but it's just steel. It's actual steel. What I'm doing now would have been exhausting to understand when I first got this machine, but because I learned every step of the way, I'm starting to feel like I'm speaking the language, you know? I feel like it really is like learning a new language. And it's cool because now I feel like I can talk to someone at a bar in a different language, you know? It's not gonna be elegant, but we can bullshit together, you know?
You know conversational Spanish now.
Yeah, that's right. Conversational G code. Okay, thread milling. Thread milling, which should be the toughest part, has actually been the easiest part of this whole process because it just works. Yes.
What you got?
Well, I'm looking for a precision cylinder with, precision something with a hole in the middle. Well, bearings are really precise. I happen to have this bucket of bearings, so I'm going to use this outer bearing race that's machined and ground as my support for my inverted cylinder, and hopefully that supports it more evenly, allowing me to mill the bottom in a more precise way. Not quite. It's like almost the wrong size. Should be smaller. See if I can find another one. Yeah, so there's an outer race to a taper bearing to support that. Mill that away. I think it was this cut here that really, when I took damn near 3/16 off in one go, that's way deeper than I should have gone. I'm pretty sure that's where I ruined the bit. User error is the main culprit at this point. I mean, I ruined this 1/2 inch. Well, I think I dropped this one. That's why I put the cardboard down, but pretty sure I hurt it before that by taking off too much aluminum. I definitely ruined this. Now this is a 4-flute steel cutter that I ruined because it came out of the collet. So it was coming out of the collet and plunging deeper into the material. And yeah, really screwed that up. I don't know how that happened. I tighten the collet the same every time. In fact, I probably over tighten it now because I'm nervous of that happening. I hear it cutting all the way around, so it's better than the last one.
Looks good.
Yeah, that was probably the best outer face so far. Yeah, that's almost perfect. So my theory now is I have this stud and I have my threads. Damn it. That's not tall enough. I think they came with one, so I'm gonna have to make one with 1/4-20 fastener cable rail fitting and just cut the stud off of that, giving me a shorter 1/4-20 stud. Let's see if that vertical bandsaw was set up. Cut off wheel. Now you have a machined surface, machined spacer, and the top of my machined part. And I know it's still long, but I'm just gonna write a script to mill all that off because why not? Live dangerously and wastefully. Let's turn like $50, $40 worth of copper into dust. Live, cry, mill. That's the ball mill, so I gotta get that out. Math, we're doing math. So I've got that. I've got my part screwed to the table upside down, and I've got all this stock I wanna remove. Yes, it's wasteful. Yes, it's probably making you mad, but I'm very tired of this project, and I'm just trying to get the customer his part. I didn't pay for the copper, he bought the copper. He's been patient with me. I've been able to learn a lot throughout this, so it's all gravy. But I am going to waste quite a bit of copper in the next 10 minutes of this video. So strap in. In this video, we turn a giant chunk of expensive copper into dust with the MR1. So what I need to do is measure my heights. So let's try to measure down to the bearing. It's not perfect, but my part is 2.02. So my overall, I have this, and I have my taper, and then I have flat, and then I have taper, and then I have this. So my overall is 2.02. And what I want to leave is 0.875. So I need to do 2.02 minus 0.875 equals basically an eighth, give or take, or an inch and an eighth, sorry. 2.02 minus 0.875 is 1.145. So 1.145. So I need to write a script or modify the one I made earlier that will just mill off an inch and an eighth of material, being careful not to go over, because last time I went over. Oh, probably because I didn't re-zero. So now that I've milled that, go to my XY0, go to my Z0, look at what my cut was last time, was 20 thousandths. Hey, how's it going, man?
That's it for y'all.
Thank you.
Thank you. Y'all have a good weekend.
You too. So that's zeroed. Let's do some programming. But I'm tired of trying to use a bandsaw to slice off little parts of this copper, so I'm just gonna turn it into dust.
Excuse
I should be using the fly cutter attachment, but now is not the time to introduce a new tool to this freaking project. I will use the fly cutter for something else. Sure. Could be. I can even add some audio. Yeah, we got audio, baby. It's Hunter Flieger, everybody.
Oh.
Drinking some of that bean juice, cut. Woo! Let's go. Let's get freaky with it.
Freaky fry.
Let's see if there's any catastrophe that comes from that. So far, so good. The way I programmed it, it should leave like an eighth of an inch almost left on the part. So I shouldn't over mill it this time like I did last time, which means that one's gonna be fine. This one will be okay. I think that was the last cut. And I got that from looking through the G code here, the history on the machine, because the last time it moved over, The last time there was a Z move that wasn't raising the tool up. Oh yeah, actually minus 1.25. Go over to continuous, slow speed. I think that's it. Turn the spindle off, take a piece of paper. Ooh, that's gotta be it. That's for sure it. Okay, great. So now I'm at my Z0 point. I'm at the level that it cut last. So I'm gonna zero that. And now I should be good to just run a 20 thousandths facing pass and this part should be done. Okay, so let's go into facing. Depth 20 thousandths, we'll add a finishing pass, generate the program, and what could go wrong? There we go, that looks bad. Oh, that was an illusion. This part should be very, very close to perfect. If it's way off again somehow, I don't have enough brain power to know why. I've done everything in my limited capacity to get this as close as possible. Now it's gonna do one more finishing pass to make it perfect. It's like an under thousandths of an inch cutting pass. So you got the best surface quality. So this part should be perfect. All right, what could possibly go wrong if I just run this thing? Oh, stop. What are you doing? Why would you go down into the probe? You know the probe's right there. Good Lord, you can save this thing from itself. It goes down first. Seems backward. Now we're going. We're in good shape. That one's gonna be salvageable. And it's being re-squared. That one wasn't squared up. Okay, stay up. Awesome. I have two that are done and perfect enough. That one's too small. This one, I just realized the problem. I don't think my initial pocket was deep enough for reasons I now understand. That's close. I know why it got weird. It's because it was, had to sand it down. Yeah, that one's fine. I'm not gonna mess with it. How would I measure? I don't know how to measure in there. 0.15, 0.105. Subtract that from, this one is 0.125. All right, well, I just touched them all on the wire wheel to make a uniform finish. And there they are. These are the 4 parts that I've been able to make. I think they're close enough to each other to achieve what the customer wants. They're not perfect, and I know they're not perfect. 2 of them are more or less identical. One of them's really close, and one of them is about 10 thousandths under. It's 0.865 instead of 0.875, but I hope that's close enough. I hope with, the floor that the thing's sitting on, there's gonna be one that can be shuffled around to get it to sit evenly. So all I know is I've done my best, and I learned a lot along the way. And, I could spend a million hours polishing these things, but there they are. I think that's it. I definitely need to move on to another project. I'm gonna call the customer and let them know they're done. I'm not gonna charge them probably gonna charge them for a third of the actual time that it took me to make these, but there you go. 4 copper Rolos made from the MR1.
Looks like.
Pretty cool. Final thoughts. This was really challenging. This pushed me beyond my comfort zone several times. Tested my patience, it tested my focus, it tested my ability to measure things precisely and do math. But I learned a lot. I now am far more comfortable with CNC machining than I ever have been. In fact, before this project, I really didn't know how to program for CNC machining. I didn't know how to do the fusion side. I didn't know, how to zero things. I didn't know how to change tools. I didn't know how to use some of this stuff. Shout out to Langmuir and the MR1 here. It's by far the most affordable and the easiest or the least difficult way to get into CNC machining, I think. They do a lot that makes it easier to pick up. I would say easier to start with something like this than to buy like a 20-year-old milling machine, from the 90s and like learn how to program for that and learn, find parts for it. I think it's much easier to start with something like this that has support and that has tools and accessories and, a pretty long path forward. From unboxing to leveling to attaching the vise to making my first fixture, I had to make this aluminum fixture in order to hold this copper cylinder. That was a good practice. Aluminum is nice to mill, copper is really nice to mill. I broke a few bits along the way. I'm sure there's something else I broke that I can't remember right now, but I'm very pleased. I'm proud of myself. I'm proud to stick it through. Thank you to the customer who has been patient with me as I limp through this job. And this is the 5th one that I made that is too short, so I get to keep this as a souvenir. I made myself a nice paperweight for my desk. But I'm tired. I need to move on to some other projects. It has been an absolute joy to expand my knowledge into this world. And I feel really comfortable now, or at least confident moving forward, that I can limp my way through another part. And maybe more than limp. Maybe I can walk normally through another project. So yeah, overall thoughts, everything that went wrong had nothing to do with the machine. It was all user error. The machine did great, never hiccuped once. Very, very happy with how it works. I'm happy with the amount of working area here. There's a lot of parts that we're gonna be able to make. And I'm very much looking forward to the next one. Hopefully, it doesn't have this freaking tapered side, so things are a little easier to hold on to. But adapt and overcome. Thank you for watching. Thank you for joining me on this long, painful journey. I hope you guys learned a lot. I hope if you have a machine like this, or even any CNC milling machine, there's probably a lot that I went through that's relevant to your pursuit. So, yeah, thank you for watching very, very much. Check out everything that Langmuir offers, langmuirsystems.com. Really, really good guys. I've met a lot of those people at PRI, and they care about what they're making. They stand by it. There's a dedicated support person for every single machine that they sell. Jake is the guy who you'll be talking to when you call about this machine. And they're very, very helpful, and they want you to succeed. So they will answer all your questions. So check it out if you're interested. Otherwise, happy milling, happy fabbing, happy crafting. Thank you so much for watching. Consider joining our Patreon if you want to support us in that way. You saw the list of people at the beginning of the video. Those are all gracious patron members, and they get ad-free videos and dedicated content and all sorts of stuff. And who knows, maybe I'll put the file like this, the file for this part, up on Patreon for you to download if you for some reason want to make that. Thank you for watching. Goodbye. I'll see you on the next one. Like and subscribe, please. It means the world. Thank you so much.